Hey all, so we're going to do another set of problems from chapter 4, and these ones are going to talk about divisibility. So get yourself ready for notes and we're going to get started. Now, with divisibility, obviously you've talked about numbers being divisible before. There's going to be a little bit of new notation for divisibility, which you'll see if you're looking over here at the start. And the idea is that if we're given just two integers, because that's when we talk about divisibility, we only are talking about whole numbers in that case, we would say that x divides y like this if y is equal to k times x for some k in the integers. So it's the same idea as what you would expect before. It's just this new piece of notation. And then a nice algebraic expression, you could also think about it as y is a multiple of x, x divides y. They're both similar ideas. So when it comes to notation, that's what's going on there. Number one, we're going to do some proofs. Say A, C, B, I don't know why I did it in that order, are integers. If A divides B and B divides C, then A divides C. So this is going to still be direct proof, so we want to start with our hypothesis here. And so we can say that A divides B, which means that B is equal to some constant, and I'm just going to use subscripts, K1 times A, and B divides C, which means that C is equal to some constant times B, where K1 and K2 are in the integers. Now what we want to do here is use substitution, and you can even write that out. So like by substitution, using these two equations, we know that C is equal to K2 times B, which is K1 times A. Now I'm going to use the associative property here to say that that's the same as K2 times K1 times A. And here's where we're coming back to the idea of closure. So we can say since the integers are closed for, in this case, multiplication, then K2 times K1 is equal to another constant in the integers. So C is equal to Ka, which means that A divides C. So it's basically like the transitive property of divisibility. And this is what most of your divisibility proofs are going to look like. We might have ones here where we have to look at some clues in the way that it's set up to do a little bit of solving. So here it says that we have A, B, and C as integers. And here we're going to start with A divides B, which we've similarly seen before. So that's A times K1. And in this case, A divides C. So instead of B dividing C, it's A. And I've changed my order. It's multiplication. It's commutative. And now here's where you have to use your logic. You're like, okay, this is our hypothesis. This is our setup. And you'll notice in the conclusion, it says A divides B plus C. So therefore, we know that we want to add B plus C. Now, this isn't necessarily something you would know without looking at the proof. And so since we know this is what we want, that tells us what our next step will be. So I'm going to say, what's B plus C then? Well, that's A times K1 plus A times K2. Well, hopefully you would then use the distributive property to say, well, that's A times K1 plus K2. And now we have a multiplication of B plus C. So since the integers are closed, in this case it's going to be addition for addition, then K1 plus K2 is equal to another element of the integers. And B plus C is equal to AK, meaning that A divides B plus C. So don't forget to look at the actual full statement of your proof, which is going to give you some good guidance on where to go. Let me know if you have questions about any of the new notation, and I'll be available by Zoom, email, or in the comments.